Hello and welcome to my session for DevOps Stage 2023. I hope you have had a great event so far. We're going to talk about building and managing application platforms with Azure Kubernetes Service. So who am I? My name is Robert. I'm that guy up there. I work as a principal cloud engineer at Mesto 42, based out of Oslo, Norway. Microsoft MVP, CNCF ambassador, and HashiCorp ambassador for the things that I do with the community for speaking engagements like this, and in general just doing open source stuff. I'm in the very active in the CNCF under the tag App Delivery, where I am one of the co-chairs of the platform's working group and also one of the maintainers on the Open GitOps project. I do a lot of other things as well. Feel free to connect with me on LinkedIn or any other social media, and you probably will, see what I'm up to. But keep on saying yes to everything, so I'm a little bit everywhere. Anyway, so today we're going to talk about platforms and even more platforms. It's not going to be 100%, theory. We can also have some demos. As much as it's possible to do so on such a scale. But we're also going to talk about why Kubernetes, because obviously this talk is called, has Azure Kubernetes Service in the title. We're gonna talk a little bit about some concepts like infrastructure code, immutable infrastructure in general, and GitOps as one of the things that I want to point out towards building platforms. So to kind of take a little bit of step back, I tend to reference abstraction layers when I talk about these things to make sure that everyone's kind of comfortable with the idea, because I have been in a lot of different platform teams, or sometimes, mistakenly called DevOps teams, and been kind of that platform person all along. But I always felt that there was something missing, and then it turns out that more or less everyone else has agreed with me. So that's why we have things like platform engineering now. But still, if we talk about the abstraction layers of a system, we have the end users, which are the people who are using said system. They obviously need support and need some, way of reporting back to you, giving feedback on the things that is happening. And that usually ends up at the application and services level, where you have, your developers, product managers, et cetera, who are creating these services that people are using. And then, at the bottom, we have the physical infrastructure, and in a, post-cloud world, that is obviously something we don't have to think a lot about, but there are some people who are running around, pulling servers out and stretching cables and all those kind of things. But as a kind of platform or, cloud engineer or whatever you want to call, the modern IT ops role, we tend to be slotted in at the public cloud level. Which works. It's fine if you have for instance, only one product that is created, and you have set of developers who are doing certain part of that service, and then you have the people who are creating everything on the public cloud for them. That can work, but what we often see is that there's different teams that have different needs, but it's kind of the same need, and for everyone to be, I usually reference the full stack developer. Now it's not only full stack developer, it's full stack. So the people who are developing are not only doing backend and front end services and maybe like the data layer, but they are also doing security and automation and everything in between. And that obviously doesn't scale very well. So what happened, the last couple of years, that we started introducing this kind of like platform service layer, where we started introducing platform engineering, which is a big topic, but in general, it's about creating platforms as a service or platform as a product, and think of the users of that platform, even if they are internal developers, that look at them as customers as well. Like, what do you need to solve your thing? You need a database, and it's has a couple things, like for instance, it needs to be a document database and not so very specific there. But other than that, really don't care. What kind of service can we then provide you that will solve your need without you having to think too much about what's going on? And this platform service thing is something that we talk a lot about in the platforms working group in the CNCF. And when we started that, we first started off by writing a white paper. So that's called that's the CNCF platforms white paper. And in there, we try to define what a platform is and kind of all the different components of a platform. And this picture is from that white paper. I think it's a very good representation of what we now kind of see as a platform, because before, when you ask what is a platform, depending on where you work and what kind of experience you have, you would have different things that you would say this is a platform. So on top, we have our product and application teams. They need to interface with the platform somehow, and that could be as easy as there's documentation on how to even go into Azure and right-click the thing. Don't do that. That's not a great idea. But documentation on how to get started. It might be project and environment templates. So it might be terraform modules that you reuse. There might be terraform root modules that you reuse, which is more defined, or anything in between, or even Helm charts. So if you you can spin up something through a Helm chart or different templating solutions and get stuff up and running. We have these web portals or user interfaces where Backstage is obviously the one to kind of pull out from those, and you could even create this yourself if that is within the context of what you're supposed to do, or you could abstract the platform through an API and create CLI tools for that. So you can see like there's no right answer here. We're just as a side note, the platforms working group is working on a platform maturity model where we speak about these things. And one thing doesn't you don't have to be mature. You have to level up on all aspects, but it's important to know where where you want to head it and where you want to focus on to build and spend time on. And that's the interface, and then you have the platform capabilities. And traditionally, it's usually, you go back to when VM started becoming a thing, people had their specifications and said we need a certain type of server with this much memory and this much CPU and so on and so forth. The idea is that we have those kind of things too, not necessarily in forms of a virtual machine, but we need compute, we need networking, we need storage, we also need a database, etc., etc. So those kind of a little bit more traditional things are also part of what a platform should deliver. And then you have everything around that. So how do users of the platform or the users of your service and or application, how do they authenticate into the solution? How do you bind the workloads, these services to workloads and secrets? How does secret management work? Do you scan the artifacts that are in there to make sure that everything is up to date when it comes to vulnerabilities? Do you enforce policies, and how do you do that? How do you do building, testing, and deployment? How do you observe, like everything that is kind of useful to run a platform is kind of what we call for platform capabilities. And then when it's all said and done, you have a set of capabilities and service providers where this is what you can expect out of a platform. And that's a lot. No one says that you need to solve all of these things to have a platform up and running. What we reference in the white paper, and this comes from the team topology guys, it's the thinnest viable platform. So the idea is that the end goal might be different, but what set of capabilities and how should users interface or interact with your platform in a way that is the quickest path to success and that you can scale out. So you might not need to implement certain parts of that diagram right away, even though in most cases you probably should. So again, it says Azure Kubernetes Service on the front of this thing. So Kubernetes is a foundation. So Kubernetes is kind of get a bad rep from the developer side of things, and sometimes also from the IT ops side of things. So Kubernetes might seem like a very hard to run and hard to learn, set of tooling, but you actually get a lot of things out of the box that is it's stuff that we've been doing for years and years. Some of these things go back to the 60s and 70s concept-wise. So what you get out of the box with Kubernetes is things like container orchestration. That is probably the thing that most people think about. You solve the idea of bin packing. So bin packing is a problem where you have a set of items, and you have of different sizes and shapes, and you have a set of bins of different sizes and shapes. And how could you best optimize how to fill those bins up in an efficient way? That is what we call bin packing. So in our case, this is various size containers, and that has different requirements, and then we have these nodes underneath, and how do you then bin pack in a efficient manner. We also have a lot of self-healing things, so we have these probes and all this functionality around the containers, where when something starts going awry, you can kind of either stop that and restart that process, or if something crashes, we can get it up and running again without having downtime with the user. So it has all this self-healing aspects. There's an extensible API. So the API for Kubernetes is the thing that I usually try to talk as much as possible about when it comes to Kubernetes, because that's kind of where the superpower is. There's an API where everything is defined as resources. So you don't necessarily have to know how this container should run, because that is inside a pod, and that follows a specification that is controlled by something called the deployment, and so on and so forth. So at some point you just say, I need a deployment, it should look like this and run this container, and that's all you need to know. So it's declarative. You say, I want a deployment that looks like this, and then the rest is Kubernetes doing its thing. One of the great things about this API is it's extendable. So we have custom resource definitions where we can add new resources to the API, and this is where all these CNCF projects kind of come into play, and among other things, GitOps works by doing this, and we will specifically look at that afterwards. And it's cloud native. It's kind of the definition of cloud native, but it's one of the first real cloud native pieces of technology that came out, and it's modular. So even though it has RBAC, even though it has secret management, even though it has some aspects of networking, it doesn't really solve all those things. But what it does is create the opportunity for the cloud hyperscalers to come in and kind of fill that gap. So when you're in Azure and you say you want to enable traffic in, it would automatically create a load balancer and a public IP. If you need a place to store data, it will automatically create a data disk, or whatever you define it as, and mount it and make sure that it's available for the pods. You don't have to think about that. That is part of the implementation of Kubernetes in that cloud. And this is why it's been so successful, because Kubernetes is very kind of big, and you can basically run your entire thing, everything on Kubernetes. But if you would have to solve all those things every time you do it, no one would have adopted Kubernetes. But luckily for us, it's been created in such a fashion where the hyperscalers can kind of fill in all those kind of things. So, that's what you get out of Kubernetes out of the box. And there are a couple things I want to highlight from the Azure side of things. So what you get is a managed Kubernetes service. Kubernetes works based on having a control plane and having worker nodes where things are deployed. There's some, if you want to run it on, you can basically run it on bare metal, and you have your clusters of nodes and everything like that. And there's a lot of things you have to think about when managing all this, and it gets kind of complicated. But through Azure Kubernetes Service, you can basically just say, I want Kubernetes, and the nodes and everything underneath there is none of your concern. Like, Microsoft will take care of that, and you can just decide on which version you want to have running, and then you can concentrate on the Kubernetes aspects of it. And obviously, like I said, it's integrated into Azure, so Azure have many products and services that you probably would use while creating your application, and you can integrate them directly into Kubernetes cluster in a fashion that makes sense. So we're also going to look a little bit about that later on. But what I'm going to do, I'm also going to talk a little bit about GitOps, more specifically Flux. That's what I'm going to show off. Flux is the original GitOps tool. It's created at WeWorks, and they kind of coined the term GitOps, which we later took into the CNCF and modified some of the things that were said in the blog post from 2017 or 16, and kind of made that the definition of GitOps. So the things that we think about when we think about GitOps stems from Flux. There's a set of resources that Flux adds to a system, to the Kubernetes system, where and a set of controllers that then make sure that this happens. We're going to look specifically what that is in the demo. It works with just regular Kubernetes manifests, but it also supports customize, which is what we're going to look at today, and it has a good integration of Helm. So it's not you writing Helm templates and then putting it into Flux, but if you have your Helm template and charts and have that somewhere, you can define in an easy fashion that this is what you want to do, and it basically just runs the Helm CLI tool at that point. So it's you can troubleshoot using the Helm CLI tools on your machine and so on and so forth. So it's a very native way of adding Helm support into it. And it's available through the AKS add-ons. So Azure Kubernetes Service has add-ons for certain things, and it has a GitOps add-on, and the GitOps add-on basically just install Flux. So this seemed to also be a trend in different hyperscalers and different cloud vendors, that Flux is very much like a kind of like back-end type tool, a platform engineering tool, while others might be more catered directly towards developers. All right, so you're doing things in Kubernetes, that's cool, but how do you deal with the different types of multi-tenancy and environments? Because obviously at some point you have different applications written by different teams that have different requirements. So there's two types of tenancy, multi-tenancy. It's hard and soft. So by hard, we mean literally separating the tenants. You can't really do that, out of the box at least, in Kubernetes by running them in the same cluster. So that would mean separate clusters. You could add something on top, like a V cluster and so on and so forth, to create Kubernetes clusters on top of your Kubernetes clusters, and then that being where they do their things. But that kind of depends on your requirements and so on and so forth, if that makes sense to you. I would say, at least from my perspective, if nothing else, keep production environments as a separate tenant, and then everything else could even be in just one cluster, just because you don't want the noisy neighbor problem between teams. That's one thing, but between dev, test, and all those where you do all your things, and production, maybe keep them separated. And then you have the soft multi-tenancy, where you, for instance, say every team gets their own namespace, or and the problem with namespace is that there's no restriction. It's literally just a place where your application gets to run. So there's nothing that actually stops you from directly interacting with the other things happening in the cluster. That being said, there's stuff like network policies and so on and so forth that can kind of restrict it, but as long as it's in Kubernetes, it's not really separated as long as it's the same cluster. All right, so when it comes to infrastructure in general, how do you even if you have 1 or 6 clusters, this all kind of depends on how the infrastructure is handled. So you could have, for instance, like a template solution where, from a Terraform perspective, you have a Terraform root module that you can just reuse and reuse. That has everything defined and set. You update some variables, and then you have the new cluster. If you have 1 deployment per cluster running somewhere, you could give people access to do pull requests and change things based on their need. And then obviously someone who is more of the infrastructure type person would then go through and make sure that everything is all right. Or you could go back to the abstract everything through an API or have a portal. You can have it as a service, so people just go in and say, I need a new environment, and that's how you get it. And that might be easier to do if you're doing like Backstage and have 1 cluster and people have their own namespace for every team and so on and so forth. But there's ways around that as well. So a lot of different options. I can't really get into every single one of them, but I do other talks specifically on these things. So let's do a quick demo of Flux and Terraform and GitOps and how we can get it all working together. So here we have my Visual Studio code. This is a repository called demo GitOps on my user on GitHub, and we have a couple of things I want to highlight. I have a Terraform root module where I literally just create a resource group and a Kubernetes cluster using MSL42's public module for AKS. So there's a couple of things there by default that we feel that is true, and we abstracted some things and kind of make a neat package for how to deploy AKS. And nothing major to pull out from here except that we're have Azure AD back on. We define a cluster admin group to give cluster admin, so I would get cluster admin as soon as it's up and running, and something basically in terms of I just needed some extra power for the stuff that I'm doing. So that's our Terraform in itself, and that could be running in a pipeline somewhere. It could be in Terraform Cloud, it could be in the GitHub Actions run or Azure DevOps pipeline, and then people could change values here depending on. But I tend to favor, if you have a different cluster, create a root module like this, abstract everything through variables so that you can at that point put that into these pipelines solutions, and people can update that specific pipeline for that specific cluster. But again, this is just to have a cluster up and running. And if you see here, we have 2 folders. We have one called apps and one called clusters. If we look at one of the patterns that we do Flux with is to have these clusters folder where we have our environments. They're, could be called anything, but just so you're aware, this is kind of like one of the typical patterns that we have running. And we have dev and production. If we look into production, because that's more clean, we only have 1 folder and one file called customization.yaml. And if you go into that, we'll see that this is a customization file, and there's no deployment here, but we have our base, that is this apps folder, and then we have certain items that we want to be changed, but depending on the environment that this is getting deployed into. If you look into the apps web app folder, We also have a customization that basically just says this is the manifest or YAML file that we're using. This could have been several depending on, again, this is just a demo. And inside of here, we have a namespace getting created. If you want different namespaces for this, you should probably move this from the base and until the overlay, as it's called. So this is called a customized overlay. But just to make it easy, we have basically just one namespace getting deployed, and we have a deployment and everything that you would expect from a deployment, and even a service. That's the prod folder. If I look into the dev, I see I already have Flux system, and that's because I've kind of cheated a little bit. So if I press these buttons, and I can do this, I'm just making sure that everything is okay there. So this is my cluster. And in my cluster in the namespace Flux system, we can see I have a couple of controllers, and this is what Flux, sets up when you run the Flux bootstrap command or otherwise use the AKS add-on. So we have the source controller, and the source controller's responsibility is to take source references, for instance, in this case, the Git repository, and make sure that authentication that works. If something changes, it will pull in these changes locally so the other controllers can take care of that. We have a notification controller, which whenever status changes happen and so on and so forth, we can send that to Teams, or we can send it to Slack, or different sources. And then we have the controllers who actually are doing things. We have a customized controller, which runs Kubernetes manifests. And then we have the Helm controller. So if we define a Helm deployment, it's the Helm controller that looks at that and make sure that everything works. At some point here, it's going to get a bit confusing. So I'm just going to say this straight away. Customize the template language. That's one thing. The way that they implemented this through Flux is by a customization. So the resource that makes all this work is called, I'm just writing KS for customization, is called a customization. The name of this is Flux system. That's the default if you bootstrap. You don't necessarily have to have a Flux system one, but I'm just using the default. And you can see it's ready, apply revision, and it's referencing the SHA value of the commit that's in the cluster. So if we look at this, I can press Y. We can see here for the spec, we have 10-minute interval. So every 10 minutes it's going to try to reconcile. This is the path. So clusters dev, right? So everything that's inside of here is now under Flux's control. Prune, so it's removing stuff properly when removing stuff like that. And then you have the source ref, and the kind is Git repository because we are using a Git repository. It doesn't, as one of the things with GitOps, it doesn't have to be a Git repository to be GitOps. It needs to be, your configuration needs to be stored somewhere that's immutable and versioned. That could mean an Azure storage account, blob storage, or a S3 bucket, or anything where you can't update the file directly, but you would have to put in a new version of that file. But in our case, Git repository, and the source is also called Flux system because, again, by default. So if we look at our web app namespace, we have a pod with a long name. We can look at deployment, and it says, and again, you can see that it's dev web app, while the original, let's see, remember that original deployment is just called web app. So since we're pointing it towards the dev cluster, and this customization has a name prefix, all the things are now prefixed. We can also see, oh, that's kind of weird. We can also see the labels and annotations and everything that we define. So if I go into the pod and press D for describe, you can see app equals web app, environment demo, environment dev, well, twice, why not? come from something else. And managed by a platform team. Some of these, these ones in particular, come from our overlay, right? So that's cool. So if we change something in the dev, and again, just to clarify, it doesn't have to be a customization template like this. You could have normal Kubernetes manifests, but just so you know, if you have a customization.yaml file in a folder, the customization controller will look at that and say this is now under a customization. So if you add manifests here and don't pull them in like this, it will just get ignored. But if you add a second folder here, or even in the root folder here, now create something.yaml, and it's just a regular Kubernetes manifest, Flux will pick that up. But we're going to look at a little bit how one of the ways how we can do multi-tenancy. So this will be, soft multi-tenancy. And basically, we're going to run even in the same namespace because, again, this is just for demo. So if we close that. If we look at the prod web app customization, it's basically the same thing, except it has a different replica count, different name prefix, different environment, and so on and so forth. So, one way we can do this, we could go into the Flux system and start looking into the component, not the components, this one. Because here you can see the customization defined. This is the customization Flux system, in the namespace Flux system, interval, everything that we saw in directly on the resource. But instead of doing that, I'm gonna open, a different window, and I'm gonna write Flux create KS, which is customization, call it prod, and then we have to input, this customization uses what source reference, which is then the Git repository of Flux system, and we define the new path, so not dev but in prod web app, and everything basically the same. So if I just click enter, it's going to do stuff, and if we look into the KS, we're going to see we now have a prod one. It says reconciliation in progress. Now that happened, ready true. And if we now go into not pods for everything because that's going to be confusing, we can see that now we have two prod pods up and running. As easy as that. If we now, for instance, want to scale up or something like that manually, probably shouldn't do that, but why not? We could say count 3. And I use a lot of conventional commits. So what we can do is we can say, it's not really a feature. We can just say, we can use it for chore, demo bump, replica count. And it didn't stage the file, but Visual Studio Code got my back. Hopefully, the demo doesn't stop. Oh, that's what you get for closing too much of the things when getting ready for. All right. Thank you. All right, so now it's pushed that up. And there's a slight wait before the customization recognizes that, or not the customization, but the source controller recognizes there's something new, because the customization will try to reconcile always, but it's local. So it's the source control that has to do this. What you can do, let's say it happens. Okay. What you can do is you can run Flux reconcile customization prod with source. So it reconciles the customization, but it says, I also want to reconcile the source the source resource. So it does that. It's done. We now look at pods, not and everything. There we go. Prod web is now 3 apps. So the main benefit of this is obviously now, like, we didn't change the system. I didn't go into the cluster and say, scale up to a certain number of replicas. If I do this and scale down, it's gonna reconcile and go like, no, it's actually 3. So, it's gonna solve itself because our what we reference to as the desired state is stored in Git. And unless you update Git, you will always try to get to that desired state. So, that is the main benefit there. And there's a lot of things that we can look at where that makes this, like, this is a slightly not easy demo, but it's a slightly, low key demo. It's not a lot happening here. It's basically just setting up GitOps on the Kubernetes cluster. But it's the end result of these tools and different tools that kind of make the platform. So if we go back to this one, the idea is that Kubernetes might seem difficult, but you are really, like I said, standing on shoulders of others. There's a lot of people who solve a lot of things when it comes to these platform tools. So for instance, for networking, by default in AKS, you get KubeNet, which is a simple way of integrating into Kubernetes clusters or into Azure. But you don't get a lot of flexibility there, and the way that works tend to make routing through firewalls and more advanced stuff kind of be hard to do. So they have a different plugin where every pod gets their own IP address. There's like I said, network policies and those kind of things where you can restrict traffic between. If you want to then get a more advanced networking setup, you can install something like Cilium, which is also tightly integrated into AKS, where you can get with the enterprise version, you can get not only security on a whole different level, but you can also get traceability between on a packet level and through eBPF. Think about how you want to do networking before deploying these clusters. I want to highlight something like Cert Manager. Updating certificates manually doesn't happen anymore. We have Cert Manager, which has been a part of the CNCF for years now, and basically we can automatically deploy not only Let's Encrypt, which is free, so you can get free certificates, but if you have some sort of requirement that says that you have to have a certain type of certificate, you can, as long as your CA or your issuer of the certificate supports the ACME protocol, you can have automatically renewing the certificate and automatically inject it into the ingress of your traffic. So that's all taken care of. GitOps, obviously, I show Flux, but there's also Argo. Both of these projects are now graduated in the CNCF, so they are really mature and they have been implemented at the biggest, most advanced enterprise levels to small mom and pop shops, and it just works. Speaking of progressive delivery, so you have on the Flux side you have Flagger, and on the Argo side you have Argo Rollout, where you can define, if you deploy a new version of your service, that you could side by side set up that as a pod and start routing traffic, percentage wise into the new application. And if there's no errors, you could go all the way over. So you can automatically get basically a smooth transition to a new version of the application. And I just noticed that I'm kind of in the way because of the green screen thing. But security and policy, you have stuff like OPA. When you're doing the Azure policy add-on, OPA Gatekeeper gets installed on your cluster, and even though this is in Azure, OPA is open source, and you can add your own policies on top of that comes from the platform. Speaking of which, when you're doing AKS deployment, there's a couple of things that people have a tendency of not doing. Use Azure policy add-on. You get so much out of the box there. You Kubernetes, like I said, that's the kind of the default. It's fine for sandboxing, but for anything else, please use something more appropriate when it comes to the network. Auto upgrade. There's no reason why your cluster should stay the same version forever. So there's a lot of auto upgrade solutions in Azure. Go look through them and kind of see what makes sense for you. But you can then supplement with, for instance, if you can't upgrade to new image versions, so the operating system that is on the node, you could install something like Cured, which when the patching happens automatically on the node image level, but sometimes when there's security patches, you have to restart the node for it to be operational. At that point, there's a file that gets created on the machine that says needs to restart, and Cured looks for that and then can move your containers from that node to make sure that it's free and available to restart, so it can restart automatically. Besides that, on auto upgrade, there's stuff like the pod disruption budget and all those kind of things that make sure that you can potentially just allow your clusters to auto upgrade whenever needed. And you would always have a certain amount of room to wiggle between. So pod disruption budget, basically you can say that at any point in time we need to have this many pods up and running. So for instance, if you say that you need to have 2 up and running and you have 3, at least that one node can go off one pod that can go off a node, and that node can then restart and do its thing, and then you kind of have to shift back and forth, so on. Azure RBAC should be on. Allow Azure to take control of the RBAC situation. You can also then say that you don't want any local accounts on your cluster, so you remove all those potential vectors for misconfiguration and so on and so forth. And by default, the Kubernetes API is online. It's a public cloud, so you can either restrict that by IP or make it a private cluster. So all the traffic against the API will then have to go through Azure, and you could do that through Bastion hosts and VPN and so on and so forth. But at least put in and restrict based on the IP range, so that you at least don't have it completely open to the internet. All right, it looks like I'm basically at time. If there is anything that you want to discuss when it comes to platform engineering, DevOps, Azure, Kubernetes, even stuff like CNCF and so on and so forth, I'm available on these platforms. At least some of them temporarily, who knows, but at least on LinkedIn. I'm going to be on LinkedIn forever. So feel free to reach out, let me know if there is anything that I can help with. And I hope this was useful, and have a good rest of your DevOps Stage 2023. Thank you.